So for here, so this is Chapter 1, Section 2, Measuring and Constructing Segments. So when we use a number line, a coordinate is going to be a number that corresponds to a point. So in this particular number line, -2 is going to be the coordinate of A. So a coordinate is always the number that's associated with that letter. And then 2 would be, for example, the coordinate of D. When we want to find the distance or the length between two coordinates, we are going to find the difference. We're going to subtract. Now, you can do two things here. The official way is to find the absolute value of the difference of the coordinates. However, if you just do big minus little, then you don't have to worry about taking the absolute value of the two numbers. So in this particular problem, if they want me to find how long it is from A to D, I can either do 2 minus -2. So the bigger number was 2, and my little number is -2. Keep flip change. 2 minus -2 is 2 plus 2, and I get 4. Now, if you don't do the big minus little, that's when you're going to have to do the absolute value. So if instead you decided to subtract A minus D, that would have been -2 minus 2. You would have gotten -4, and that's where you need to absolute value it. Because distance is never a negative number. So the length of something, a segment, will never be negative. Now, you could also have counted the gaps. I could have counted 1, 2, 3, 4, and there's 4 spaces here. Sorry here, let me see. All right. Back to this. Okay, everybody good so far? Still see my screen? Okay, let's go on to the next slide. All right, so we have a definition here, and we have the word postulate. And a postulate is a statement or a rule that's accepted without proof. Now, we're also going to be learning about theorems, and a theorem is a rule that can be proven. And we're going to talk about theorems coming up, but for right now, just know that a postulate is a statement accepted without proof. It's a rule, sort of like a definition. Hold on, I gotta let somebody in here. Internet problems. Okay. So our first postulate, postulate number 1, is called the ruler postulate. Now, throughout the course, all of our theorems and postulates are going to have numbers. We're not concerned about memorizing the numbers. All I want you to do is memorize what those theorems or postulates state. Because the problem is, postulate number 1 in a different textbook could really be postulate number 2. And the way that textbooks name theorems and postulates is the first time you learn something, that's postulate number 1. Then the second postulate that we learn about in this textbook would be called postulate number 2. So again, we're not going to memorize the numbers, just memorize if it's got a name or what it tells you to do. So the ruler postulate states that the points on a line can be matched 1 to 1 with real numbers. Once a coordinate system has been chosen in this way, the distance between any 2 points equals the absolute value of the difference of their coordinates. And that's really what was said on the previous slide. Now, you can also find the distance when you're using a number line just by counting the spaces. So let me give you another example of the same thing I just did on the previous slide. Let's say I draw a number line here. Let me add some numbers. -1, 0, 1, 2, 3. I'm going to add variables or points A, B, C, D, E. And let's say I ask you to find the distance or the length of EA, or it could be AE. Remember, when we name a segment, the order doesn't matter. So we have really 3 different options here. We can either decide to count how many spaces it is from A to E, and it's 1, 2, 3, 4 spaces. So we would say that distance is 4. Or we can do like it says here and subtract. So we could do E minus A, or we could do A minus E. But again, if we do this one, we have to find the absolute value. So this is really big minus little, and this one's little minus big. So if I do 3 minus -1, keep flip change, and you get 4. But if I did it this way, it would be -1 minus 3, and I get a -4. So this is why we have to find the absolute value, because again, distance or length is never a negative number. Pretty good? Okay. Next slide talks about construction. So again, in this course, I am not going to be grading you on your geometric drawings. Okay, so a construction is just a geometric drawing that uses a limited set of tools, and generally those tools will be a compass or a straight edge. Okay, so again, I'm not going to expect you to go out and buy a compass or a protractor or a straight edge and make exact drawings. Okay, if ever you're asked to solve a problem, if it helps you to draw your own picture, that's fine. But again, I'm not going to give you a question and say, draw this picture. Okay, everybody good? But just understand what a construction is. All right, next, we're going to talk about congruent. The symbol for congruent is an equal sign with a wave on top. Let's see if I can make it better. So it looks like a little wave on top of an equal sign. That's the symbol for congruent. And when I refer to 2 objects being congruent, those 2 objects are going to have exactly the same size and exactly the same shape. Now, right now in this chapter, we're going to specifically talk about line segments that are going to be the same. So, for example, like if I were to talk about objects, what I would do is I could have 2 triangles, and then they would be exactly the same size and shape. When I'm talking about line segments, I would have 2 segments, and this could be segment AB, this could be CD, and they're either going to be labeled with numbers. So I could say this has a length of 4, so this would be 4, or they may have little congruency marks, these little tick marks. This also indicates, so if it didn't have numbers, so let's say it was just a line segment and a line segment, A, B, C, D. If it had these kind of markings, these are congruency marks, and you could also tell that they were congruent by those markings. So if I wanted to write a statement, I could say that segment AB is congruent to segment CD. So this would be read as AB is congruent to CD. So again, they're going to need to either tell you that they're congruent by having the little congruency markings, or just tell you how long each one is. Pretty good? Can you still see? Okay. Let's try our next postulate. So again, we don't worry about the number. It's just the second postulate that we're learning in this textbook. So postulate number 2 is called the segment addition postulate. Now, we're going to be using this probably in proofs. If you want to abbreviate segment addition postulate and call it SAP, segment addition postulate, when we're writing it as a reason and a proof, you can. But if you want to write out all 3 words, you can. So what the segment addition postulate states is that if B is between A and C, then AB plus BC equals AC. Now, this statement right here does not say that B is exactly in the middle. All it says is it's in between. So for example, if I were to draw a line segment and put A and C here, and then put B somewhere in between, doesn't have to be right in the middle, then what this segment addition postulate states is that if I put some numbers here, let's say AB is 2, and let's say BC is 6. If I want to find the length of the whole thing, so this little piece from here to here is 2, and this little piece here is 6. So if I wanted to find out how long AC is, I can use my segment addition postulate, and I can do AB plus BC's piece, and that gives me AC's length. So AB would be 2, BC is 6, and that would equal 8. So this is the segment addition postulate. Now, they can also tell you that if they show you that this is true, then you can state that B is between. Again, it doesn't tell us that B's in the middle. It just tells us that B's somewhere in between these 2 points. Now, you might also get questions where I give you the length of the entire segment and I want you to find a little piece. So then instead of adding, we're going to subtract. So let me draw another example here. So let's say we have same segment, but I'm going to put different numbers here. So I still have AC. I'm going to put B in between. And I'm going to tell you that the entire segment equals 5. And this little piece right here is 1. I want you to find the length of BC. So again, if you use and say this little piece, AB, plus BC's piece, remember it equals the whole thing. So if AB is 1, I could call BC X because I don't know what it is, and then set that equal to the 5. To find the little missing piece, I solve this algebraically by subtracting 1, and the missing piece is 4. So the length of BC on this problem would equal 4. Pretty good? So it's pretty simple. You'll have questions like this in the homework. Anybody still need this slide? So a lot of
I
this,
have a question.
yes.
So if these were lines and not line segments, would this still work?
No.
Okay.
Okay. So if this had arrows here, but if they're still referring to segment AC because they have like bars on top, then you could do it. But you can never find the length of a line because it never ends. Good. Okay. So a lot of this course, you will be setting algebraic equations up and you will be solving for different pieces of the picture. All right, let's try one with graphing some ordered pairs, and then we're gonna figure out if the segments are congruent. So just a quick review. Again, when you graph coordinates or ordered pairs, remember in an ordered pair, it's always x, y. So the first number is x, second number is y. So when you graph, you go side to side, and then you go up or down second. So if I were to graph point J, I'm going to go over to the left to -3, and then I'm going to go up to 4. So this would be point J. Then for point K, I'm going to go over to the right to 2, and then up to 4. So it wants me to determine if the length of JK equals the length of LM, if they're congruent. So let me go ahead and graph L. You're going to go over to the right to 1 and then up to 3. And then you'll go for M over to the left and then down to -2. Now, what we could do, because we have a coordinate plane here, and we have little squares, we could find the length of JK and the length of LM just by counting the little squares. So JK, if you count the squares, 1, 2, 3, 4, 5. And if I count little squares on the blue one, 1, 2, 3, 4, 5. Because they both measure the same length, I would say yes, these are congruent. Now, let's say you weren't given a coordinate plane. You could also just take the ordered pairs and subtract them. So for JK, -3, 4, and 2, 4. So the numbers that are different, those are going to be the numbers you subtract. Now, you can either do big minus small, and then get 2 plus 3 and get 5. Remember the definition said to find the absolute value, but as long as you do bigger number minus smaller number, you don't have to worry about absolute valuing it. I can do the same thing for LM. So my coordinates for LM are 1, 3 and 1, -2. So the ones are the ones that are the same. So I'm just going to do 3 minus -2, and again I get 5. So I could state that JK is congruent to LM. And just remember, if you're graphing something on a coordinate plane, and if when you connect the points and it's a horizontal line or a vertical line, you can just count the little squares. If it's a diagonal line, you can't. You would actually have to subtract them and do the distance formula, which will be coming up. I believe that'll be in Monday's lesson. Everybody good? All right, let's do some sometimes, always, or never questions. So again, these are our, you had to do some in the homework. So these are our like true false questions on steroids. They're a little bit more challenging. So here it says the length of a segment is blank negative. So is it sometimes negative, always negative, or never negative? So the length will never, good. Distance is never a negative number. So here, if point S is between R and V, then S blank lies on RV. So I could give myself a visual. So if it's in between here, it will always lie on RV. Doesn't matter where it sits. Could be right in the middle, could be really close, but as soon as you see the word between, it's always going to be on that segment. And then here, a coordinate can blank be paired with a point on a number line. And this is always. This is our ruler postulate. Pretty good. All right, let's try the last example. It's sort of like what I did in the notes, but this time instead of me giving you numbers, it's going to be expressions. But it's the same idea. We're going to use our segment addition postulate. Let's try it. Now, notice a picture wasn't given to us. So I'm going to go ahead and draw a picture for myself because it sort of helps me see the problem a little bit better. So I'm going to go ahead and draw my segment. It says J is between points I and K. Draw a segment. My endpoints are I and K. And all it says is J is between. It doesn't say it's in the middle, just it's somewhere in between here. So I'll put J there. So now, instead of them giving me like a number or how long exactly IJ it is, they're giving me an expression. So from I to J, this is 2x. From J to K, it's 4x minus 6. But then they give me the length of the entire segment, and it's 30. So notice it's broken down into 3 different parts. The first thing we're going to do is find the value of x. Then once we get that value of x, we're going to plug it in. So I'm going to write my segment addition postulate, because if you remember, you can take ij, add that piece to jk, and that will give you the entire piece, which is ik. So now I'm going to take ij, it's 2x, jk is 4x minus 6, and then ik is 30. So I've substituted right now. So here's where my Algebra 1 skills come into play. I need to combine like terms, so I can add 2x plus 4x. I'm going to just rewrite the rest of my problem. And now I have a 2-step equation that I need to solve. I'm going to add 6 to both sides. It's gone from the left. 30 plus 6 is 36. Divide by 6. And x equals 6. So that's part A. Now they want me to find the length of ij. So they actually want me to come back up and figure out how long this is. So I just found out what x equals. So I'm going to take ij equals 2x from the beginning of the problem. And now I'm going to substitute and take out the letter x, put in the 6. and the length of ij is 12. Now, at this point, to find jk, I can do two things. I can either take what jk equals, 4x minus 6, again, plug in the 6 for the x, 24 minus 6, and get 18. I could have also, right here at this step, because I knew the length of the whole thing was 30, I could have subtracted what I got and gotten what was left over for JK. One way that you could double check yourself is just remember, once you get these two, you could plug those in here and double check that 12 plus 18, it needs to equal 30. If it doesn't, you've done something wrong, maybe made a simple calculation error. So you could always use it to check it. So this problem needed the segment addition postulate to solve it, and then also using your Algebra 1 skills. Everybody good? Any questions? So we will be using a lot of our Algebra 1 skills throughout this course. It's just not dealing with shapes, it's actually applying all those Algebra 1 skills. And it's good because it keeps your algebra skills fresh for when you start Algebra 2 next year. Any questions? Let's see, I've got a message in chat. Let's see. Okay, so what you can do now is just make sure your notes are good. And let me open this again. All right, so make sure everything looks good. You need to turn these in before 9:55. You do have homework over the weekend. Your homework, if you go to Canvas, is going to be, where am I in? I'm out in Algebra 2. Let me switch this. Let me go ahead and stop the recording on this.